moving on to the second part of my video where I'm going to compare tryptic soy agar and tryptic soy broth. So first up, we have tryptic soy agar, or TCA. It is like a solid, nutrient-rich landing pad for bacteria. Like if you imagine it as like a microbial playground where bacteria can grow and form visible colonies. TCA is a fantastic when we want to observe and count individual colonies, making it perfect for isolating and identifying different bacterial species. Think of it as creating a microbial neighborhood on a plate, okay? Now, let's talk about its counterpart, tryptic soy broth, or TCB. This one is the liquid form of the culture medium, providing a cozy broth for our bacterial buddies to thrive in. Visualize it as a nutrient-rich soup where bacteria can freely multiply and party together in a liquid environment. TCB is excellent for studying the growth characteristics of bacteria without the constraints of a solid surface. So in a nutshell, TCA is like a solid landing pad for bacteria to set up shop and form colonies, while TCB is the liquid hot tub where bacteria can freely swim and multiply. Now let's move on to the microbiome. Picture it as a bustling community of microorganisms, a diverse ecosystem within our bodies. These microbes play a crucial role in our health, from digestion to immunity. It's like a tiny bustling city of bacteria, viruses, and fungi coexisting in and on us. So next we have a broad spectrum antimicrobial drug. It kills off not only the target bacteria, but also the normal microbiota in your body. Now, this can sometimes lead to a not so friendly visitor called Clostridium difficile, or C. diff. It's a bacterial infection that produces toxins causing colitis or inflammation of the colon. C. diff often shows up after a course of broad-spectrum antimicrobials. It's a nasty bug that can result in severe diarrhea, and you might encounter it in soil, water, or even poorly processed foods. Hospitals are also a common place to pick up this unwelcome guest. Now, moving on to the nasopharynx, here is where things get interesting with symbiotic relationships. In the nasopharynx, Streptococcus pneumoniae engages in commensalism. Picture this, the bacteria chill in the nasopharynx, right? And grabbing some nutrients from the host environment, but the host, that's us, is totally unharmed. It's like a friendly coexistence, no harm, no foul. But symbiotic relationships can take a turn In the same nasopharynx, Streptococcus pneumoniae can switch to a parasitic mode. Now, it's not just taking nutrients, it's inducing inflammation, leading to pneumonia. Here, the host is harmed by the bacteria's presence, causing a disease condition. And finally, let's talk about symbiosis. It's a close friendship between two organisms, like us humans and bacteria. There are different types. Commensalism, like I mentioned earlier, where one benefits and other is unaffected. Mutualism, where both organisms benefit, and parasitism, where one benefits at the expense of the other.